Electrochemistry. Electrochemistry is a branch of science in which we are going to discuss about chemical energy into electrical energy and vice versa. That is electrical energy into chemical energy. Fine. In this class, we'll go for electrical energy into chemical energy. That means how the substances are going to be prepared and all. See, some important lines we'll discuss first. The process we are going to discuss is electrolysis. Electro means by using electricity, lysis means we are going to break the compound. Lysis is breaking of the compound. Electro means by using electricity. And here we need a cathode and anode. Cathode is negatively charged, anode is positively charged. Sorry. Cations will be moving to cathode, anions will be moving to anode. Cations move to cathode, get reduced, reduction takes place here. Anions are oxidized, so oxidation takes place here. Anions get oxidation, cations get reduction. So actually what happens? Let's go with aqueous NaCl solution. Aqueous NaCl means NaCl plus water. Up to some concentration, you can call this as brine solution also. So sodium chloride on dissociation gives sodium ions and chloride ions. At the same time, water also get dissociated to form H plus and OH minus. In simple sense, if you want. So now there is a competition between two cations, Na plus and H plus, which will be moving towards the cathode first. So both can move, both possibilities are there. But of these, hydrogen goes first and gains electron and becomes H2. Now in these two, chloride goes first, lose electrons and becomes Cl2. What happens in the rest? Sodium OH is remaining, they will be remained in the solution, they join to form sodium hydroxide. Now the question is, why H plus is going first towards cathode than Na plus? It all depends on SRP values. Standard reduction potential value. The sodium plus reduction potential value is very high than H plus. That means sodium doesn't want to get reduced easily. Sodium doesn't want to convert into Na easily. H plus, where it is easy comparatively. So based on SRP values, you can decide this. Okay, that we will be discussing in this lesson in detail section later. So first example. Second example, if you take sodium chloride solution, okay, now molten, then you will be getting here Na plus and Cl minus. No water is there, not aqueous solution. So mandatorily it will be going to cathode, becoming sodium, going to anode, losing electrons and becoming Cl2. If you are taking two chlorides, you can write Cl2, or one chloride means half Cl2 you can write. So this is at cathode, this is at anode. Cathode is negatively charged, anode is positively charged. When we were discussing about galvanic cell, their anode is negative, cathode is positive. Here cathode is negative, anode is positive. This is the major difference. Chalo. We'll see some more examples. For example, first group cations, second group cations and aluminium. Means sodium, potassium and all this, magnesium, calcium, aluminium. When we are taking aqueous solutions of these, we don't get metals. Metals are not obtained. We will be getting always hydrogen. Means the reduction of sodium or potassium or magnesium, calcium, aluminium is not easy in the presence of H plus. Instead of these, H plus will be reduced. Okay, that's why we should not use aqueous solution if you want metals. If you want metals, you should not use this. Fine. Then what we should do? Molten you can take. Molten salts if you take, like sodium chloride molten, just now we have discussed. magnesium chloride molten if you take. Yes, you will be getting magnesium at cathode, chlorine at anode. Right? We should not use aqueous solutions. Second point is sulfate ions and nitrate ions. These also always give O2. They don't give you sulfur dioxide or nitrogen dioxide type. They always give O2. That means O2 is coming from actually OH minus. Okay, SO4 minus to NO3 minus, whether they are aqueous solutions or molten solutions, whatever it is, they will be always releasing O2. Okay, generally O2 comes from OH minus if you are using aqueous solution. If you are using molten also, in such kind of cases also, O2 is only coming, not SO2 or NO2, such kind of compounds we don't write, we write always O2. If you have transition metals like copper, here you can use aqueous solution very comfortably. Copper and oxygen you are going to get. This is cathode product, this is anode product. Fine, it's very simple. Zinc chloride, if you are using aqueous solution, you are getting here zinc and you are getting here chlorine. And here also one interesting point is there. If you are using AgNO3 here, silver and O2. And in general, we use cathode platinum, anode is also platinum. Platinum electrodes we generally use as cathode and anode. But if we use, for example, see this is very interesting. Copper sulfate aqueous solution is giving you copper sulfate ions and sulfate ions, right? What we expect, this will be going to cathode, fine. This will be going to anode, we expect. But if we use copper electrodes, means instead of platinum electrodes, if you are using copper electrodes, then this is cathode product and anode product is very interesting. You will be getting Cu plus 2. That's why this kind of copper electrodes are called active electrodes. Cathode product is same, anode product is going to be completely different. That means whatever the ion you are getting, the same ion is going to be discharged at anode. One more example I will give you. Just see AgNO3 if you are using. Ag and Ag plus if you are using silver electrodes. That's why the silver electrodes are called active electrodes. Copper electrodes are called copper electrodes. If you are using same metal salt, same metal as electrodes, okay, now generally two examples are given to you. One is AgNO3 and this one. AgNO3 at cathode gives you silver, at anode Ag plus. And the reason is active electrodes. Active electrodes means the electrode itself turns into the ions. Okay, this is one important point. And some exceptions if you want. Calcium hydride molten, if you see, it will be giving you calcium plus 2 and H minus, not H plus. So you will be getting calcium no doubt, but hydrogen at anode. Generally hydrogen is obtained at cathode, but here hydrogen is at anode, that's why it is special. This is at cathode. One more example generally asking is 50% sulfuric acid. H2SO4 if you are using hydrogen at cathode and at anode it is H2S2OH. All these are actually exceptions. So you will be knowing all this if you are studying inorganic chemistry in depth. Fine. Now here we are discussing just what are the products. Okay. For example, solution, electrode, platinum cathode, electrode, platinum anode. Fine. Aqueous NaCl if you take, you will be getting here hydrogen and chlorine. Molten NaCl if you take, sodium and chlorine. Fine. Aqueous Na2SO4 if you are taking, hydrogen and oxygen. Sulfate always gives oxygen. If you take molten Na2SO4, then also you will be getting here sodium and oxygen. Okay. Calcium chloride molten if you take, molten or fused meaning is same. Calcium and chlorine fused Al2O3 if you are using aluminium and oxygen. You must be very good at this. As I told you, aqueous copper sulfate will give you copper and oxygen. Aqueous copper sulfate will give you copper and copper plus 2 if we use copper electrodes. Active electrode sponge. Active electrode sponge, right? Similarly, silver nitrate also. I don't make you bore. This is first part of electrolysis. After this, one more part is there, that is Faraday's laws. The first law of Faraday is, two laws are there. The first law of Faraday is Q is directly proportional to, not Q, sorry, M is directly proportional to Q. Very simple. Your marks are directly proportional to your studies. Fine. The mass deposited is directly proportional to the quantity of electricity passed. Quantity of electricity. It is given in coulombs. Q is equal to, we write C and T, where C is current, which is given in amperes. T is time, time is given in seconds. Q is equal to CT. Okay, now, so M is proportional to CT also you can write. Or M is equal to, if you remove that, you will be taking one constant, which is called electrochemical equivalent. Is called electrochemical equivalent. So when Q is equal to 1, if Q is equal to 1 coulomb, coulomb spelling you see, COU or COLOU, okay. If Q is equals to 1 coulomb, then M is equal to E na? Right? So mass deposited by passing 1 coulomb electricity is electrochemical equivalent. One more definition I will give you. Chemical equivalent. Mass deposited by 1 Faraday. What is the relation between 1 Faraday and 1 coulomb? 1 Faraday is equals to 96,500 coulombs. What is this 96,500 coulombs? Actually, it is charge of 1 mole electrons. 1 mole means 6.023 into 10 to the power of 23. Each electron charge is 1.6 10 to the power of minus 19 coulombs. If you multiply this, you will be getting there 96,500 coulombs. Okay. So the simple sense what we can say is, instead of writing this formula and all, simple sense what we can say is 1 Faraday means 96,500 coulombs deposits 1 equivalent of substance. This is what we write. Chemical equivalent is mass deposited by 1 Faraday. For example, 1 Faraday deposits 23 grams sodium, because sodium equivalent mass is 23 only. 12 grams of magnesium. Why 12? Because magnesium atomic mass is 24, but magnesium charge is plus 2. So 24 by 2 is 12. Mass by charge is equivalent mass. For sodium it is 23 by 1. Aluminium, if you take 9 grams of aluminium, because aluminium charge will be plus 3 better. That's why 27 by 3 is equals to 9. 27 is atomic mass of aluminium. Similarly, 108 grams of silver. 108 you can easily remember, right? So silver charge is going to be Ag plus only. 108 by 1 is equal to 108. Calcium, 20 grams of calcium, 40 by 2. Potassium, 39 by 1. 39 grams of potassium. All these you can consider 1 Faraday. And the interesting point is 11.2 liters hydrogen at STP or 1 gram. Hydrogen equivalent mass is 1 gram hydrogen. 5.6 liters of oxygen at STP or 8 grams of oxygen. 11.2 liters of chlorine at STP or 35.5 grams of chlorine. These are also deposited by 1 Faraday. 1 Faraday can deposit 11.2 liters of hydrogen, 11.2 liters of chlorine or 5.6 liters of oxygen. This is first law. Second law is, for example, we have 3 different solutions. First one is with AgNO3, second one is with copper sulfate, third one is with H2SO4 like this. Now we are connecting them and passing same amount of electricity. When more than one substance taken in when more than one container is taken and they are equipped with different electrolytes, but the condition is they must be connected and same quantity of electricity is passed. So all these are aqueous solutions. So tell me what are the products here? Silver and oxygen, correct? Here copper and oxygen, correct? And here hydrogen and oxygen. So what we say here is mass of silver is to mass of copper is to mass of hydrogen is to mass of oxygen are in the equivalent ratios, equivalent weight ratios. Or if you want to take only 2, mass of silver by mass of copper, this ratio will be equivalent weight of silver by equivalent weight of copper. Mass of hydrogen by mass of oxygen is equals to equivalent weight of hydrogen by equivalent weight of oxygen. You take any relation. Mass of copper by mass of hydrogen is equals to equivalent weight of copper by equivalent weight of hydrogen. You want to take 3, mass of silver is to mass of hydrogen is to mass of oxygen is equal to equivalent weight of silver is to equivalent weight of hydrogen is to equivalent weight of oxygen. When same quantity of electricity is passed, you can say like this. When same quantity of electricity is passed through different electrolytes connected in a series, the amounts of the substances deposited will be in the ratio of their equivalent masses. The masses deposited at cathode or anode are the gases liberated at cathode or anode that will be in the ratio of their equivalent masses. For example, 5.6 liters of hydrogen is liberated when connected in a series and same amount of electricity passed. What volume of oxygen will be liberated? We know hydrogen equivalent mass is 1 gram or 11.2. Okay, 11.2 liters of hydrogen when it is coming. Oxygen will come 5.6 liters. Just now we were writing here. Oxygen 5.6 liters, hydrogen 11.2 liters. When hydrogen itself is coming 5.6 liters, so oxygen will come. Yes. Okay. If 10.8 grams of silver is deposited, how many grams of copper will be deposited from copper sulfates? So mass of silver by mass of copper is equal to equivalent weight of silver by equivalent weight of copper. Mass of silver is given 10.8, mass of copper you need to find out. Equivalent weight of silver is 108, equivalent weight of copper is copper atomic weight is 63.5, charge is plus 2, so beta by 2. You can do, na? Such kind of calculations you need to do. And after this, there are some important definitions actually. That part we'll discuss later. Thank you. This is your Lucky Sir.